the researcher from Intellectual Data Analysis Department in Data Advance, and today I'm going to present you our webinar about design of experiments in pSeven to improve further data analysis or optimization operations. If you have any technical problems, please contact the host. And also, if you have any questions during the presentation, please write to the host and to the presenter, and we will answer them at the end of the webinar. Here is the agenda of our today's talk. First of all, we will talk a bit about the motivation and some general definitions of design of experiment and its usage in pSeven, and then we will consider main techniques about design of experiment in pSeven, and we will try some demos to demonstrate them in the tool. And so let's start. First motivating example from the real world is the following. It is about design of side panel of Formula 1 car, and you can see the picture of the side panel on the right. Here it is. It is a bit. It has a bit complicated composite structure, and the task is to minimize mass of such panel in order to fulfill some strength constraints, because this side panel should protect the racer during his work. The problem here is that one can calculate the mass and strength constraints for the given side panel configuration using some finite element analysis, but it takes a long time. Also, one could create this model and prepare the crash test, and also calculate some these strength constraints and calculate mass. But this will take even more time and will be even more expensive. So the possible solution is to create something called surrogate model, and we will talk what is surrogate model a bit later, and to use it to create it using experimental and numerical data, and then optimize it and just check the solution using few calculations of numerical solver, and if needed, a real-world experiment. And as a result, we achieved 10% mass reduction with less number of simulation and full-scale experiments. Well, the next example is about high-pressure turbine disk design. You may see the picture of this tool on the right. And here the problem is again to minimize mass and also to maximize life of such disk. This subject to some geometrical and also strength constraints and some other constraints. Again, the problem is that to calculate all constraints and mass and lifetime, one needs to prepare several time-consuming calculations, some numeric finite difference calculations, and it takes long even for one configuration. But we need to calculate it for different configurations to prepare some optimization procedure. So again, the possible solution is to create surrogate models for each constraint, each objective function, and when prepare the multi-objective surrogate-based optimization to get the Pareto frontier here. So you can see that this is the Pareto frontier, the set of optimal solutions for two-dimensional optimization, which is constructed using the classical method, and here is the one which is calculated using our tool, and inside it macros GTOpt, which is also a part of our tool. And here we also reduced the number of time-consuming calculations and get even better optimization. So, what is the surrogate modeling? To answer this question, we need to introduce some general definitions. So, let X be the vector describing object design. For example, for this picture, it could be some geometric configuration of aircraft, and let Y be the vector of object characteristics of this design X. For example, for this aircraft, it could be lift and drag coefficients and some other characteristics. Also, we suppose that there is a known rule which maps object design X to the object characteristics Y. And this rule could be calculated through, for example, some CFD code, some numerical simulation, or using physical experiments in wind tunnel. And the goal here is to find object with optimal characteristics, or possibly to explore some behavior of this unknown rule. Well, each calculation of such rule can be expensive, such as experiment in wind tunnel, or time-consuming. For example, CFD codes are very time-consuming. But it is still possible to perform several experiments or several numerical calculations and form a database using it. We usually form the database as the following. For each experiment or numerical simulation, we have the one row, for example, here. And then we put all input components into different columns. For example, one column for angle of attack, one column for the Mach number. And then we put all outputs also into different columns. For example, here it is lift coefficient. Well, then we put all our information into different rows and form a table like the following. Well, when we form this table, we call the input components as X, and we call the output components as Y, and we call the whole table as training sample. And our goal mathematically is either to find the rule f hat which somehow approximates unknown rule f, or to find an objective with optimal, in some sense, maximal, minimal value of characteristic y. And the answer here is, are there any alternatives to direct computation of f? And the answer is yes. We can use so-called surrogate model for the unknown rule f. What is surrogate model? Surrogate model f hat is some function which should be fast and cheap to evaluate and simulate behavior of x. In other words, it could be formulated as the following. Consider the training sample, which here represented on two-dimensional plot. Here, for example, one here one point corresponds to one experiment, and its X projection is a value of an input, and its Y projection is for outputs. And using this training sample, we construct a surrogate model. Here it is represented as the blue line. And if one wants to calculate the value, to approximate the value of unknown rule in new point, it needs to set wanted input, for example, this one, and then the tool will answer him and will provide him or her the expected output value, for example, this one.